An amide is a functional group that simply has a carbonyl that is connected to the nitrogen. So the whole thing here is considered to be an amide functional group. And the bond normally that connects the carbonyl with the nitrogen, this is considered to be the amide bond. And that bond is the weakest bond. So in reactions, when I am doing reactions, it's this bond that normally is broken because this is the weakest bond. The CCN bond is the weakest bond because nitrogen is more electronegative than carbon. To name amides, we're going to follow the same rule as we named amines. So we're going to classify amides as primary, as secondary, and as tertiary. And we're going to follow exactly the same rule in there by using the N prefixes before any R substituents for the secondary and the tertiary amide. So to name amides, primary amides, first of all, it's very important to know what type of amide that you are working with. So this one is a primary amide. Why? Because the nitrogen is connected to one carbon. Notice here that the nitrogen has a carbon and it's connected to two hydrogens. So this one is going to consider it to be a primary amide. So primary amides are simply named by choosing the longest carbon chain that is connected to the nitrogen in there. Okay, we're going to give the carbonyl of the amide the lowest possible number, and then we are going to name that carbon chain as a carboxylic acid. We're going to drop the oic acid and replace it by an amide. So let's have an example in there. We are naming this as we're going to choose the longest carbon chain. So let's highlight that. So that is going to be, let's highlight it. Okay, so this is going to be my longest carbon chain. Okay, including the carbon of the carbonyl. I'm going to start numbering from that carbon chain and give it the lowest possible number. So it's going to be carbon 1, 2, 3, and 4. So I know that this is butanoic acid because all of these amides, they are derived from a carboxylic acid. So it's a butanoic acid. After all, just a reminder, whenever we talk about carboxylic acids are RC double bond O that is connected to the OH. So if I take the OH and I replace it by N, here in this case H2 or R2 or HR, whatever that is, primary, secondary, or tertiary amides in there. This is why I'm saying that amides are derivatives of acids, because all I am doing is I am replacing the OH by any of the amide for any of the nitrogen functional groups in the amide. So this is why I name it as first derivative of carboxylic acid. Take the NH2, put an OH in there. It's going to be butanoic acid. And then we're going to go ahead and drop the oic acid out. We're going to drop that out. Take it out, and we're going to replace this by an amide. So the name in this case, it's going to be butan amide. Okay. Now, if I'm working with a primary amide, I don't have to put the 1. So please skip the 1 in there, and that is going to be a butan amide. This means that the amide bond is on carbon number 1. Now that butane includes the carbon of the carbonyl, okay, because we are choosing the longest carbon chain in there. Same thing, this is derived from benzoic acid, because if you take the NH2, replace it by an OH, that is going to be benzoic acid. So I'm going to name it as benzoic acid, and then I am going to take the oic acid out and replace it by an amide. So in this case, the name is going to be benz and an amide. Okay, make it simple because it is not that complicated. Okay, so over here, what I have is a 1 carbon chain, right? A 1 carbon chain, let's name it as an IUPAC. We can also name it as common. So that is going to be a methanoic acid. So it's going to be a methanoic oic acid. So we're going to take the oic acid out and we're going to replace it by an amide. So the name is going to be a methenamide. Okay. You don't have every time to put an oic acid and replace it by an amide, but here I'm just showing you how the name is going to be. So that is going to be the IUPAC. I can name it also as a common. And for common, I know that one carbon is formic, right? Or form. So that is going to be a formic acid. I'm going to drop the ic acid and add an amide. So that is going to be a form amide. You are responsible for form amide as a common name. So naming secondary and tertiary amide, we're going to follow the same rules as the secondary and the tertiary amine. We're going to use the prefixes N, and we're going to name the alkyl substituents that are shorter chains. These are attached to the end. So one N means it's the secondary, two N's means it is a tertiary. So starting with this first example, this one is a secondary amide. And that secondary amide has a CH3 attached to it on the side. So the name is going to be an N, a dash, and a methyl. Okay? And then on the other side, I do have my longer carbon chain, including the carbonyl. Always give the nitrogen the lowest number. So always you have to start numbering from the carbonyl. It's going to be 2, that is going to be 3. Always, you don't have an option for this one. You need to start numbering from the carbonyl. It's a 3 carbons in there, so it's going to be propan amide. Propan and an amide. Okay. In this case, and it is, you can leave a space or you can put it all in one word. It really doesn't matter. This is an example of a tertiary amide. So with tertiary amide, you have to take into consideration both R groups that are connected to the nitrogen. So here I do have a CH3, I do have a CH3 in there. These are two the same, so I'm going to do N, comma, another N and a dash. It's 2 methyls, you guys. If you just put a methyl without putting the prefix di, the name is wrong. It is not right. So that is going to be a dimethyl. Okay, and then I'm going to choose on the other side the longest carbon chain that includes the carbonyl of the amide. I'm going to give this carbon number 1 just in case if there are substituents in here so that you can number the substituents, right? But we don't have any substituents. This is 4 and this is 5. So this is going to be pentan amide. So that is going to be a pentan amide. Okay. Again, notice the difference between a secondary amide that has 1 N versus a tertiary amide that has 2 N's in there. This here is an example of a tertiary amide that has 2 different R groups here. These are the smallest chains. This is still a tertiary amide. And this one is a tertiary amide as well. Okay. So again, this is 2 R groups that are the same in this example. So let's do the first one there. You do have an ethyl and a methyl, just arranged in alphabetical order. And the name is going to be N and a dash. And then an ethyl. And then another dash. And then an N and a methyl. So I am done from the R groups around the nitrogen. Now for the long carbon chain. So that long carbon chain is the one that has the carbonyl in it. And I know this one is a derivative of benzoic acid. So it's going to be a benzamide. It's going to be a benz and an amide. Okay. For this one over here, it's going to be an N and N. I have 2 ethyls in there. Please group the N's together and a dash. And that is going to be a diethyl. And then I'm going to choose now my longest carbon chain. So my longest carbon chain is the one that includes the carbonyl, guys. So you have to include the carbon of the carbonyl. Start numbering from here. The number matters if I have a substituent. I do have a methyl on the second carbon. This is a 3, this is 4, and this is 5. So I need to put on carbon number 2, I have my methyl. Okay. And then the rest of the name, it's a pentan amide. Okay, now for the physical properties of amides. Amides normally, these are solids at room temperature. Most amides are solids at room temperature in there, except the smallest amide, which is a form amide. This is a 1-carbon amide. This one is liquid at room temperature. For the solubility, we are going to follow the solubility rule that says less than 6 carbons. These are water soluble. Because amides, and this is only for primary and secondary, because they do have a hydrogen bonding in there. So let's have an example of a primary amide. Two primary amides that are next to each other. So if I have two primary amides here that are next to each other. Okay, so primary amides up to 6 carbons. They are water soluble, and they also have a high boiling point. Why they have a high boiling point? Because of the hydrogen bonding. Normally amides, these are hydrogen donors. They do have hydrogens in there, so they can use their hydrogen to bond with another molecule of the same kind. That is a primary amide as well. Okay. Same thing, I can use this hydrogen over here to bond with an oxygen in there. So this is another hydrogen bonding interaction there. Okay, that is for the primary amide. Secondary amide is the same thing. So primary and secondary, they have hydrogen bonding and they have high boiling point. Tertiary amides, on the other side, they don't have the condition for hydrogen bonding. And the reason why, because they do not have any hydrogen that is connected to an electronegative element. So here, there is no hydrogen bonding. And because there is no hydrogen bonding, tertiary amides are considered to have a lower boiling point than the primary and the secondary. Now, for the water solubility, primary, secondary, and tertiary amide, they have the capability of doing hydrogen bonding with water. Whether for the primary and the secondary amides, those two, they do have a hydrogen on the nitrogen. So normally they are considered to be a hydrogen donor. So this is a primary amide. That is another, this is a secondary amide in there. So both, they do have hydrogens on the nitrogen. So one of these hydrogens is going to come and interact with the oxygen of the water. Same thing, it's going to interact with the oxygen of the water in there. And I would have a hydrogen bonding. So primary and secondary amides are considered to be water soluble. Tertiary amides are also considered to be water soluble, even though they don't have a hydrogen donor. They don't have a hydrogen on the nitrogen, but I can use the hydrogen on the oxygen in there. So I can use the hydrogen in the solvent and interact that with the nitrogen. So they will have a hydrogen bonding in there. But please pay attention that we are limited to 6 carbons, whether we are working with primary, secondary, or tertiary amides. All of those are water soluble because they do have hydrogen bonding up to 6 carbons.